Hello everyone. Today I am going to discuss the third problem of Leetcode Weekly Contest 435, which is minimum increments for target multiples in an array. So what is the problem? We are given two arrays, nums and target, and in a single operation we can increment any value in nums by 1, and at the end we have to find the minimum number of operations such that each element in target has one multiple in nums. So let's take the first example, 1 2 3. So nums is 1 2 3 and target is 4. Okay, so we can increment any value in this array 1 2 3, and at the end we have to find the minimum number of operations such that 4 has at least one multiple in the above array. So let's say we are incrementing the first element to 3. Okay, so by 3, so our resulting array will be 4 2 3 and 4. Okay, so 4 has a multiple of one multiple in the nums, so this is a good answer. Okay, this is a good array, you can say. So total number of operation here is 3. Now instead of incrementing the first value by 3, we can just increment the last value by 1. So our resulting array will be 1 to 4. So 4 has a multiple of 1 in it, so that's why this is also a good array, but the total number of operations here is 1. So our minimum operation such that we can build a good array is 1. Okay, now how we are going to solve this problem? Okay, so here one interesting thing is the constants. So what is the constants? Constant is the nums length could be 5 into 10 to the power 4, but the target length, here you can see target length is 4 only. Target length at max is 4 only. So after looking at this example, we can think about some brute force way to generate all the values. Okay, brute force way to generate all the values of target. So when something is less than equals to 4, so we can think about generating bit masks. Okay, so how we are going to generate bit mask? So we, let's say we have 4 elements in target. So initially I none of the elements has multiple, so all the bits will be 0 in the mask. All the bits will be 0 in the mask. Now let's say uh, after performing some operations or not performing some operations, we have the multiple of 1. We have the multiple of the first element of target in the nums, so then the bit will be set. So our bit will be 1 0 0 0. I hope you get it. That's why we will be using bit mask, because our length of the targets is quite small. So now using bit mask, how we are going to solve this problem? Okay, now we can think about recursion states. Initially we are at the index 0 and our bit mask is also all zeros. We are at index 0 and our bit mask is all zeros. Now we are encountering the zeroth index element. We are encountering the zeroth index element. So let's take this one only, 1 2 3. Okay, 1 2 3, and we are encountering the first element. So what we can do, what steps or what transitions we can do from here? So we can just ignore this element. We are not performing any operations, so we'll just ignore this element and we will just incrementing the value of our index. So we can go to 1 comma 0 0 0 0. We are not changing the value of mask, or also we are not doing any operation. Okay, now let's say another thing we can do here is that we can perform three operations. So 3 plus what state we can go? We can make this 4. We can make this 4, right? We can make this 4. So three operations are needed. Now the last bit, okay, the last bit is set, because we have achieved the multiple of the first element in the bit mask. So we can go to 3 plus 1 comma 0 0 0 1. Okay, now from that we have already achieved our desired mask. So what will be our desired mask? Our desired mask will have all the ones, the number of ones such that so number of ones equals to the count of the elements in targets. So that's why we have already achieved our desired mask. So we can just return from here. We can just return 3 from here. Okay, we can just return 3 from here because we have already achieved our desired mask. Also from here what we can do, we can perform two operations plus we can return from here. We will be 2 plus uh, what is this one? This will be 3, not 1. This will be 0 1 2, sorry, this will be 2 because this is the index. So we can do 2 plus 2 comma 0 0 0 1. So we have already achieved our desired mask, so we'll return 2 from here, or otherwise we can go to 2 comma 0 0 0 0. Okay, I hope you are getting it. So how we are making the transitions. So we'll try to set in every bit of the bit mask. We'll try to set every bit in the bit mask, and we'll go to the next index. So I'll jump to the code, and you will understand it better how we are changing the bit mask. So first, let's ignore DP, because DP is obviously DP will obviously be required for memorization, but that is not required currently. Okay, so let's ignore DP. So if I equals to n, that means we are at the last index. We are at the last index. Now if mask is equals to 1 left shift m minus 1, that means all the bits from last m elements are set. All the bits of last m elements are set, then we are returning 0, otherwise we are returning 1 in 9. Okay, if so what you can do is that you can take this condition earlier. So if mask is already set, just return 0, otherwise return 1 in 9. Okay, we can do this. Now the first step is that we can just ignore the current element. So we are incrementing the value of index mask. The same mask will be populated to the next index. A and B is required, that is nums and target respectively. Now we are iterating all the values of the target. We are iterating on all the values of target. Now that is one important thing, is that how many operations, number of operations are required to change some value of AI to BJ. Okay, some value of numSci to target. So let's say we have something like 3. Okay, our AI is 3 and our BJ is 5. So 5 should have a multiple in 3 should be multiple of 5. 3 should be multiple of 5. So in case our target j, in case our target j is greater than our numSci, if in case our target j is greater than equals to numSci, then our desired answer will be nothing but 5 minus 3. 5 minus 3, because we can just increment the value of this by 2, and we will get 5. Let's say this element is 7 and this element is 5. Now what? So for achieving the multiple of 5, we have to add 3 to here. Okay, so in that case we can take the ceiling. We can take the ceiling of 7 by 5. We can take the ceiling of 7 by 5. What will be the ceiling of 7 by 5? The ceiling of 7 by 5 will be 2, and we can multiply this by 5. Okay, we can multiply this by 5. This will be our desired value. So what is the number we have to add? We have to add minus numSci. Okay, so we have to add 3 to this. Okay, that's what I am doing here. If our target j is greater than equals to numSci, we are taking the difference between them. Otherwise this is the ceiling value between numSci by target j, and we are multiplying that by j minus numSci. We are taking the difference between them. Okay, I have explained what I am doing here. So this is our required number of operations. Okay, so now another interesting part. Let's say we are trying to set the current element, right? Let's say we have some sub array, target array, which is 2 comma 4. So we are trying to set this bit 4. So when we are trying to set this fourth bit, 2 bit will already be set. Why? Because let's say something is multiple of 4, then that is should be obviously be multiple of 2. That's why we are again iterating over all the elements and check if the new desired value val will be AI plus request. If val is divisible by bk, then we are setting that bit. Okay, we are setting that bit. So let's say our val is 8. So 8 will set the bit for both 2 and 4. Okay, I hope you are getting it. So after that we are achieving our new mask. So we are doing answer equals to minimum answer plus the total required number of operation, and we are populating the new mask to the next element. Okay, so I plus 1 new mask a comma b. Okay, I hope you get it. The rest of the part is just initializing the DP array and calling the recursion function with 0 0. So this problem is quite straightforward. We have to just think that this problem is solvable using DP with bit mask. and after that we have to find out that what is the transition state of the DP. I hope you understood how we are transitioning from one state to another in the DP. That is the most important part for a DP with memorization problem, the transition. That is important. Otherwise the other thing is we have to just add one memorization step to make the problem faster. So what is the overall time complexity? The overall time complexity is we have a mask I and a mask. So I could be till n, order of n, and mask could be 2 to the power 4, which is 16. Okay, and for each mask, we are iterating on each value of k two times. Okay, each value two times. So this will be 16 again. So 256 into n will be our overall time complexity. Okay, I hope you get it. I will provide the link of the code in the description box. If you have any doubt in any part of the code or explanation, you can always ask in the comment section. I'll try to reply each and every comment. If you find this video helpful, please like the video and subscribe to the channel, and also share among your peers. Thank you.